So this week we're working on lesson 6.05 on force and mass, and it's got this experiment with building a catapult. And it said you need these materials, but actually I looked online and there's a lot of different ways to build a catapult. So I don't really care how you build it, but you might want to try to collect some materials today so that you'll be ready to build it tomorrow. So they say you need 7 wooden craft sticks. I don't think you actually have to have that, but you need some way to brace something that will spring back. So in this case, they used a spoon that kind of will bend, but you could come up with any way to be creative and make this. 7 rubber bands, you don't need 7. A plastic spoon, the modeling clay is just the ball, but you can shoot something else. And safety glasses, you obviously, if you have some glasses around your house, put them on. Some sunglasses, I don't care. So these are your materials. I don't have these specific materials, but I'm going to go look for some things that'll work so that I can build one tomorrow. So you may want to look for some materials. This lesson is 15 pages long. We have 3 days for it. So the first 6 pages or so are just kind of about it. And then on page 5, they introduce you to the graphic organizer that you're going to use to do the experiment. And that actually is going to be your assignment on page 15, this force and mass one. And it's got, like, tomorrow we'll sit together and we'll come up with a good question and some variables and a hypothesis. We'll get that done. And then we'll start to build our catapult. Here's the materials. Here's the procedure for building it. And then you do some experiments where you try to fling things. And then you come up with some conclusions about how mass and force are related to each other. So this will be kind of fun. If you want to do it with me tomorrow, just make sure you've collected some of the materials that you need. In the meantime, let's go on a field trip. Okay, so what I'm going to do now is I'm going to start our field trip and give you a Kahoots code to join, and I'm hoping that it will work. So here we go. They're loading our game pin. 5118390. And I can expand it, but oh, here we go. Copy link to share. There we go. I copied it. I'm going to come back into our chat and put it in there. And then see, and then I'm going to share my screen, I think, and see how that goes. And we'll go on the field trip together. So here is the Kahoot thing to join it. It says waiting for players. And I guess maybe I don't have to share my screen. I'm not sure how it works. Let's see if anybody joins. It says waiting for players. Oh, Kainoa's in. Okay, one person's in. It's working.
Hey, what's the code?
The link is in the chat.
It just joined you.
Yeah, it just joined you right in. And then you should be able to see your name on the screen. Do you see your name on the screen? Right now I have Buddy.
I am.
Mickey Mouse, Sasha, Bowerbrie, Luis. Oh, I need to mark you here, Luis. I didn't mark you this morning. Hello, welcome. Good to have you here. Okay. 2, 4, 6, 8. How many of us are there here? There's 12 of us. So there should be 2 more people. 2, 4, 6, 8, 10. And I'm 11. 2, 4, 6, 8, 10.
It's not. Oh, okay, whatever.
There should be 1 more person joining.
I was supposed to put my name.
That's okay. That's okay.
No,
Eli's
not here.
4, 6, 8, 10. We're still waiting for 1 person. Who's not in?
Eli's not in.
Eli, where are you? Eli, are you there?
Oh, what?
Are you going to join? We're waiting for you at the Kahoots.
Oh, sure. Okay. What's Kahoot is it?
You need to go into the chat and you need to close whatever meeting you have on another tab and pay attention, dude.
I know. No.
Because we're waiting for you.
Wait.
In the chat, click the link in the chat. Everybody else is ready.
I was supposed to put my name like Mickey LJ, and then the parentheses was supposed to be ABC Dino.
Okay, ABC Dino is in. Here we go. We're going to start. All right, a Kahoot by Tech Tours. Split part 1, robotics fulfillment tour. There we go.
3, 2, 1. Look up.
Do I have to click it or something? No?
It says no need to answer this time.
Yeah, that's okay. Participants using older Zoom versions in breakout rooms cannot hear shared sound. Oh, great. Oh, you're not in a breakout room.
I can't hear.
I
Me
can't
neither.
hear anything.
I can't see it on my screen.
Well, I'm wondering why it's not doing anything. It's not
There's
working.
nothing I can see except
wait.
no need to answer
Well,
this time.
maybe somebody might have noticed that I hadn't clicked next. Here we go. Okay, here we go. So it says the note taker, but I'm not going to make you take notes. So here we go.
I can't hear it.
It's coming. It's kind of quiet though. Let me see.
I hear it.
Oh, here we go.
I can't hear it.
And now,
Let's go. Music.
Hello, everyone, and welcome to your Amazon Future Engineer Fulfillment Center tour. My name is Kate. I am the tour leader here at our Amazon Fulfillment Center in Robbinsville, New Jersey. I will be your guide today as you're discovering how computer science, engineering, and incredible people deliver customer orders at Amazon. Now, you may have heard me use the word fulfillment center a few times already, and may be wondering, Kate, what is that? A fulfillment center, or FC for short, is a large building that houses lots of different items that Amazon sells. When someone orders on Amazon, people and robots work together to ship the item from an FC to the customer. We have over 200 FCs around the globe. Today, we are going to investigate the following big question. How do hardware, software, and people work together to deliver Amazon orders as fast as possible? Don't know what those mean? We'll explain in a minute. On the tour, we'll stop at 3 different stations: pick, pack, and ship. We encourage you to write down the vocabulary and information you learn to help you answer our big question later. We'll start each stop by asking you a trivia question. Let's do our first trivia question now. I'm curious, what do you think is the fastest Amazon has ever delivered a customer order?
well, from the
That's
time
from a
people
customer
order,
clicking buy to the order arriving at their doorstep.
like if you went on Amazon right now and ordered, how fast do you think they could order?
20 minutes.
1 hour.
Well, I got to figure out how to escape the full screen and get to
What?
So did you guys get the question? Here we go.
No.
Here it comes. Here it comes. There. The red one is under 3 minutes. The yellow is an hour. Blue is under 30 minutes and green is 3 hours. What do you think? Click on an answer. I got this one wrong. I'll tell you.
I don't know. I don't know.
I picked the wrong one on
Get
accident.
ready. 2 more answers. 1 more answer. Hurry up, hurry up. 9. Oh, we have 30 seconds. It's going to take forever.
You can press
You haven't answered. What can I press?
skip on the top right.
Yeah, but then I don't think we get the answer, do we?
We do.
If we skip it, it will go to the answer?
Yeah, but
I'll try it because I do know the answer. Ready? Here, I'll try skip. Yep, under 30
I
minutes.
knew it. I accidentally pressed.
You guessed only 3 people got that right.
Wait, this one has
Oh, look, you get your score. How funny. Sasha's in the lead because she answered fastest. And then Vivi and then Mila. Nicely done. I guess I don't get to vote.
The correct answer is under 30 minutes.
so quiet.
That's so fast. It takes Amazon around 24 hours or about a day to deliver a customer's order. So how does Amazon deliver customer orders so fast? it's actually pretty complicated. But for now, there are 3 words you need to know. You'll hear these words a lot today. These words are hardware, software, and system. Let's learn what they mean. Get your notes ready.
You don't have to take notes, but remember that
Software is the instructions that tell a computer or a robot how to work and what to do. People sometimes refer to
Like the
software
brain,
as code or computer programs.
Good, I
Basically,
like that.
anytime a computer or robot does something, it's following the code or program in its software. Most software works with hardware, the physical parts of a computer or device. Stuff you can touch, like computer screens, scanners, robots, and machines which you will see in our fulfillment centers. When hardware and software work together to accomplish a task, it makes a system. A system is a group of parts that work together to complete a specific task. At Amazon, hardware, software, and people work together to make our delivery system possible.
Now, some of my teammates are going to help us decompose or break down each step in the Amazon delivery system. Let's meet your tour leaders.
Hey guys, my name is Trinidad, here in San Marcos, Texas. I'm Tony from Minnesota.
Hey, I'm Pat from Miami, Florida.
Thanks, tour leaders. They'll teach you what happens at each station in our tour. But before we get to the first station, let's review what you've learned. You've got this.
Here we go. Is this just a review or is this a quiz?
You have to press next.
Well, I don't know if oh, that was the same video I just watched. Never mind. Next. Here comes the quiz. The robots used to carry the pods are an example of hardware, software, algorithm, or system. Hardware is red, algorithm's yellow, software is blue, system is green. 1 answer, 2 answers, 3 answers, 4 answers, 5 answers, 6 answers, 7. Hey, come on, guys, vote. The robots used to carry the pods are an example of 8 answers. Maybe I can't.
I'm mostly a look it person.
Let's see. 8 answers. Is anybody else going to answer? Come on, guys. Get your votes in. Last chance. Just click an answer. You've got a 1 in 4 chance of getting it right. 25% possibility. Okay. Woo! Hardware is the answer. The hardware, because it's an actual machine. It's not like programming. It's just a machine. So all of that is hardware. 2 people got that right. Let's see who it was. Oh, it was Sasha again and Vivi. Well, I don't know if it was Vivi who got it right because I think Vivi had that score before.
No, Nora.
It was Nora. Nora has joined us. Here we go. Oh, another quiz. The robots know where to go because blank programs its path using code. Because hardware programs its path using code, because sensors programs its path using code, because software programs its path using code, or because system programs its path using code.
I might know the next answer.
Well, we have 9 answers. One more answer coming in. Roll it in, roll it in. What's it going to be? One more answer. Come on. 5 seconds and I'm going to go to the answer. 2, 3, 4. Yes. You got a 1 in 4 chance of getting it right. Oh, there we go. 5 people got it right. Software. Nice. So the programs themselves are the software. Oh,
Coming, boys.
you're coming up the roads. Yeah, nice. We've got new people on the board, but that Sasha's going to be hard to beat. Next.
Are you ready for our tour?
Every time she comes on, she's quiet. Oops, sorry.
Welcome to the first stop on our tour, Pick. As we explain what happens at this stop, be sure to keep our investigation question in mind. So what's the first thing that happens after someone clicks order on Amazon.com? Well, let's find out.
Take the money out of your bank account.
When someone orders on Amazon, our computer system uses an algorithm to decide which fulfillment center should process the order. An algorithm is a set of instructions or rules that a computer follows to perform a task. It's a type of software. In this case, the algorithm first looks to see which fulfillment centers have the ordered items in stock. Then, the algorithm assigns the order to the FC that is closest to the customer and that will provide the shortest delivery time. This is how software kicks off the order fulfillment process.
Pretty cool, huh? So, next, once an order is assigned to an FC, we need to find out where exactly that item is stored. And this is hard because our FCs are huge. Some are as big as 18 football fields.
Wow.
Inside an FC, items are stored in tall, movable shelves called pods. Instead of having someone walk from pod to pod to pick up the items, Amazon engineers built robots that can pick up and move the pods on their own. Robots are an example of hardware because they are the physical parts of a computer system. Now, our robots are small, but they are incredibly strong. They have enough muscle to lift 1,500 pounds. They could literally lift a cow if you asked them nicely. Now behind me, you can see our robots in action, moving around the shelving pods that hold some of the smaller products sold on Amazon.com. The robots are in charge of finding the correct pod with the customer's items in it. But how do the robots know where an item's located? Well, before I tell you, I'm curious about what you think. How do you think Amazon arranges and stores items in each fulfillment center? And remember, it's okay if you don't know the correct answer. We'll review in a moment.
How do you think Amazon organizes and stores items in each fulfillment center? Randomly with no organization, by their color, orange items, green items, blue items, by their purpose, cleaning, sports, clothes, or alphabetically by name? You guys answered fast on this one. I'm amazed. I did not know those robots existed. 8 answers, 2 more answers coming in.
What? They have a cow?
They don't have a cow. That was an example. But I don't know. I don't know the answer to this one. So go ahead and guess because nobody knows.
Okay.
Last guess. Come on in. You're going to run out of time. 15, 14, 13. Come on, last guess. Get in there. Oh, come on. Click the button. They're not going to click it. Okay, the answer here was randomly no organization method. That's insane.
No one got it.
Yeah, because it's crazy. How does that work? There's no organization method. Those little robots are just driving all over the place. That's
I saw you would think it was like a name or like color or like something else.
You would think it was.
You would think it would be alphabetical.
To understand how and why we choose to store items randomly in our FCs, you need to understand how our robots and people work together. The robots bring the pod with the customer's items in it to a picking station. And at the picking station, an employee uses their hands to pick the item out from the pod. The employee puts the item in a bin to be sent to the pack station. Now the robot returns the pod to the FC floor, and this is much faster than having people search around for products themselves. But how do the robots know where to go? Well, let's find out.
To keep pods and robots organized, Amazon engineers designed the FC floor using a grid system. In the middle of each grid square, there's a unique QR code. As a robot drives around, it uses a sensor to scan each QR code and determine its location. These sensors are hardware that take in information about the robot's physical environment. When the sensor reads the QR code on the floor, it then uses software to update the robot's location to the computer system. In this way, hardware and software work together, so the system can know where all the robots and pods are at any given time in the FC. Software also keeps track of all the items in the FC. Some FCs have over 14 million different items, and the computer knows where they all are.
Wow.
When a new order arrives, the computer system uses an algorithm to pick the fastest combination of robot, pod, and pick station. The algorithm gives the robot exact driving directions to fetch the pod and deliver it to the picking station as fast as possible.
So, back to our trivia question. Why are things stored randomly? Well, to avoid robot traffic jams. Since the computer software knows where every item is, it doesn't matter where they are stored. In fact, it's faster to have items spread out. This is different from how items are organized at a store.
Most stores put like items together. People go to the toothpaste aisle to get different brands of toothpaste. This organization method works at the store because people need to find things easily. But it's actually slower for robots. If all the toothpaste was in one place in the FC and 5 robots needed to get toothpaste, they might go to the exact same place at the same time and have to wait in line. This would slow everything down. When using computer science, we can spread items out randomly and avoid traffic jams.
What a cool example of how hardware, software, and people work together to build a system. But what if a robot breaks down or an item falls off of a pod? If something goes wrong, a robot technician can go onto the FC floor and help troubleshoot or solve the problem. Robot technicians wear special vests that emit radio signals to keep them safe and prevent robots from running into them. It's always important for engineers to plan for possible mistakes and errors. Wow, we have learned a lot at this station about robots, sensors, and algorithms. Now before we go on, let's pause for a second to think about what we've learned so far.
It's almost book clubs.
I know. When Maestro Janny comes, I'll let you guys choose to go to the book clubs. I'll open the rooms, but until then, we'll just keep going, okay? After the item is placed in a tote, the picker taps a sensor. The sensor is an example of software, hardware, algorithm, or system. I think I know this one, but I don't get to vote. I think that's sad. I do like games. All right. It was hardware, so it's an actual item like a button or something. That's hardware. Wheels are hardware. Actually, the physical things are the hardware. Nice. Let's see who got that one right. Sasha again. Oh no, Mila maybe. Mila's up there, second place now. Okay.
Okay, we're said.
Hardware, software, and people work together at the pick station to form a, oh, this is an easy one, sensor, database, system, or algorithm. They work together. Hardware, software, and people work together at this pick station to form a, and remember, you get more points if you answer faster.
No, I picked the wrong one again.
Oh no.
Same.
Does it tell you right away if you got it wrong?
No, because I tried to press the other one, but I accidentally pressed the other one.
Really? All right, we got 7 answers. Last 3 answers coming in. I think we only have about 5 more minutes, so
Maybe.
here we go.
1 more minute.
System. They form a system. Only 2 people got that one, huh?
I missed.
Oh, Sasha got it though. Oh, Mila got it too. Oh, Mila's only 100 points from Sasha. Wow.
Flipped.
Gonna have an upset.
The next step in our journey is the pack station. To get there, we're going to send you on a ride on a conveyor belt. I'm going to shrink you down to fit inside one of these bins and send you off. And remember, keep your arms and legs inside the bin at all times and show your ticket to Tony on the other side. Hold on tight.
For a minute. That was Maestro Janny. Just a minute. Is that you, Maestro Janny?
That's me.
Okay, we're sort of like 2 minutes from finishing this little part.
Oh, don't let, I just will wait.
Okay.
No, you don't even have to
Okay.
stop anything. I just wait till you say my name. That's fine.
Hello again, everyone. Tony here, back in Minnesota. How was your ride? Not too fast, I hope. Is everything where it should be? Well, fantastic. Welcome to the next stop, Pack. Now that items have been picked by our Robot Picker Wonder team, it's time to pack those items into our famous Smile boxes. So, before we start, let's see what you think by answering the next trivia question. Amazon ships all sorts of sizes of packages. Some are really tiny, and some are really big. Now, how does a packer choose the right size box?
How does a packer choose the right size box?
Um,
They're getting better about this. They used to send giant boxes. Okay, so the first answer, red, years of training with the experts. Yellow, use rulers and tape measures on each item and work out math. Blue, follow on-screen commands based on previously recorded item measurements. Or green, pick the box which simply looks big enough. They surprised us before with their random organization. What's it gonna be? I see 6 answers.
I think I clicked on the wrong thing.
You think so?
But just imagine if it's years of training with the experts.
You know what? I'm worried it's going to be like the random green one. Just pick the box which looks big enough because of the last one where they were random.
Oh, true. I'm gonna fly.
I don't know though. I think I'd vote for blue, but I'm just not sure. All right, here we go. Last minute here.
Answer.
Two more people haven't voted. Anybody? Your last 5 seconds. 4, 3, 2, 1, go.
Yes.
Oh, it was the blue one. So this time they're being formal about it. Sasha is still ahead, but we've got Vivi on the screen. All right, I'm gonna pause this. So guys, if you're in the book club, I'm gonna stop this just for a second. If you're in the book club, let's go ahead and go to book club. I think there's just one more little recording anyway, so it's okay. And let me open the breakout room and you guys can head to room 1. If you're in the book
you.
club. Have fun. And make sure you tell them about Thursday's timing change
Wait, we're having a change of time?
on Thursday. Go ahead and go to room 1 if you're in the Untitled Book Club.
Goodbye?
Make sure I tell them
Oh, about your time change on Thursday.
Thursday. Yeah, I will.
I see Amadi is there. Come on, Liam. Who else is in that group? Amadi, Liam, Kainoa, are you in that group? Did you go?
I don't think so.
Oh, are you a reading Warlord? Are you an
Oh.
Untitled?
Oh, come on. I forgot.
Untitled.
I forgot me.
Oh. Who else? Let's see. Not Christian, not Eli. I think that's it. Okay. All right. We'll continue. Oh, no, not Eli. Okay, I think we're good. All right, let's go back to the end of our field trip. Here we go. Uh-oh, did I get it going?
Answer is following on-screen commands based on previously recorded item measurements. Let me tell you the how and why we do this. Amazon sends out a lot of packages, and we have a responsibility to ensure that we're doing everything in our power to limit our impact on the environment. So we try to be as efficient and use as little time, electricity, packing materials, and gasoline as possible. For example, when packing orders, we use the smallest box we can. But how do we do that? Well, an item like a book, a game, or a water bottle arrives at Amazon to be sold, we record many pieces of data or information about it, like its height, its width, and the weight. We use software to store these pieces of data in our computer system. Instead of storing the data on a paper in a binder or a bookshelf, we store them electronically in a database. Let's learn what a database is.
A database is a place where data is organized and stored, typically in a computer system.
I always say data.
Amazon's database knows the size and weight of every item in this FC, over 14 million different items. When an item is ordered, a computer program looks up the item's size and weight in the database. The software then uses an algorithm to automatically calculate which box will be most efficient based on that item's measurements. This helps us pick the best box for each order.
Pretty cool. And if someone orders more than one item, the algorithm will add the measurements of all items together to pick the smallest box possible for the whole order. So, what happens at a pack station? How do we actually get customer orders in the box? The pack process starts when a bin arrives at a pack station. The employee pulls the bin into the station and scans the item's barcode. Now the barcode triggers the computer software to look up information, data, about the item that the employee is holding. The software runs its calculation and automatically tells the packer exactly which box to use on this screen. The tape machine uses an algorithm too. Since the computer knows which box the employee is using, it also knows how much tape is needed to build the box and spits out the exact amount of tape. Voila! The perfect amount of tape comes out. The item goes in the box with the air pillows if needed, and the tape dispenses and the box is sealed. Wow, we've learned a lot at this station about how a database helps make Amazon more efficient. Before we go on, let's pause for a second to think about what we've learned.
Something determines exactly which box to use for the items being packed. Is it hardware, robots, sensors, or software? Ooh, I think they said this one. You got 3 answers.
What's the question again?
What determines exactly which box is going to be used for the items being packed? Is it hardware, robots, sensors, or software? I think they said it. This time I think they said it. But I could be wrong. These are tricky. There we go. All right. Oh, I was wrong. Software. I thought it was sensors. I got that one wrong. But you know who didn't? Sasha and Mila. All right, here we go. One more. And we have like 3 more questions. The tape dispenser that spits out the right amount of tape is an example of hardware, robots, sensors, or software. I think I've got this one. We have 4 answers. 5 answers. Come on, guys, be brave. What happens if you get it wrong? Absolutely nothing. You might as well guess. There's no downside. There we go. Hardware. So it's an actual machine. Good job. You guys are getting better and better at picking out those hardware answers. Ooh, Vivi moves up. All right, close out part 1 of the tour. This is the end of this half of the tour.
An employee adds a special label to the box. This label is a barcode, and it helps the computer knows who order it is. It's kind of like a secret code or a license plate to a car. When I look at it, I can't tell who it belongs to or where it's going, but the computer can. This special label helps keep customer information private while still getting the box to where it needs to go. That concludes pack. Now our order is ready to be shipped. So, you know what time it is. Buckle up. I'm sending you for a ride on the conveyor belt and over to the shipping station.
My favorite part. Woo! Whee! Hardware, software, and people work together to pack items at fulfillment centers. This is an example of a system, an algorithm, a database, or a sensor. I think you have this one, guys. You want to answer? Remember getting that answer in fast really helps. Ooh, 5 answers. That was quick. Hardware, software, and people work together. Big clue. All right, 5 answers. This seems to be what we're getting these days. Here we go. A system. Yay. Congrats, you finished part 1 of the tour. Head back to Kahoot's course for the second part of our tour, and we will do that tomorrow. Well done. Have a good afternoon. Let me know if you have any questions. I'll be on here for a little while if you need any.
Bye.
Bye, guys. See you.